Hello everyone, welcome back. We're building battleships in Minecraft with circuits and logic and magic. Let's have a look what we've got so far. Let's put the music back on. Okay, so far what we've got is a way for one player to guess one or the other, and for another player to the first player to pick one or the other, and the other player to guess which one the first player picked. So if I pick that, it's going to light those bulbs because I guessed correctly, and then it's going to reset the circuit after a short delay. If I choose this and then pick a completely different one, I don't get the lit bulbs, but the circuit still resets. So what we've done is, at a very small scale, made the game of Battleships. Now, you would have had to have been here for the first two parts to get my full and exhaustive reasoning about why this is the game of Battleships, but basically it's just at a smaller scale, right? You could do these kinds of circuits for each button in a grid of 10 by 10 or 3 by 3 if you still want a life after that. You could do these in a grid of 3 by 3. So the first player could pick could pick 3 of 9 possible options, and then you could remove the buttons, and then the player 2 would have to guess some of those 3. Now, the bulbs tell us, because of the circuit that we've got going here, the bulbs tell us when the guess was correct. But how do we know when the guess wasn't correct? Well, for that we've got to use a little bit of brains. To begin with, I'm just going to try and model this quickly because it's been a while since I've done this. But actually, you know what? Hold on a second. I just want to go into another map that I've got, which already has the command for detonating TNT. What did I call this? It's probably this one. Oh. Now, I've already done these circuits in another map in a completely different version and extrapolated out to a 3 by 3 grid. But the thing that I wanted to get was the command to summon exploding TNT. So summon primed TNT and then the location you wanted to summon. Okay. So let's go back out of this. Should be this one. Show me the grass. Yeah! Okay. Summon primed TNT. I'll remove these and I'll use this. And what I'll do is I will go quite high up. Well, sort of high up. Like here. And then I'll get these coordinates. Summon primed TNT 81215 minus 852. Boom! Perfect. One more above. Okay. So that's this command. Right, so let's put this command in here. We don't need the slash. And let's make another command block here. And what this will do is, when someone picks a value and the other person guesses it correctly, or let's see, guesses incorrectly first, just resets the circuit. Not great. But when someone picks a value and another person guesses it correctly, boom! Woohoo! That's pretty cool. Basically, you sunk my battleship. Okay, so that's what happens if it's a good guess. What about if it's a bad guess? What do we do then? Well, I'm going to use this, and I'll do the same over here, because I want to redirect this redstone signal. And then what I'll do is I will have a line of redstone. What do we want to do here? The redstone block summons here. So let's go out like this. Let's go out like this. Just put this grass block back. And we're going to have another AND gate. We've already seen that when the player selects something here, this redstone block is primed. But only when the other player guesses correct value, will there be a redstone block here. So what we can say is, if there is no signal here, but there is a signal here, then the guess is incorrect. Does that follow? You following that? Now how do we do that? Well, we can just use another AND gate. But we have to make it slightly different. What we want to do here is we want to invert the signal. We basically program in reverse. We say, okay, for this command block to fire and say you guessed incorrectly, what we need to do is have two true values. If we have an incorrect value here, if we have an incorrect guess here, we will have a redstone signal here, and we won't have a redstone signal here. And so this is the condition we want to convert to true true. We'll just invert this block. Like that. Let's get another line of redstone. Let's build an AND gate. This may seem mighty confusing, but think about it for a little bit after the stream and you'll see it's actually not that bad. Direct the redstone signal into there, and let's just say wrong. I don't know what else we can do there for effect. Anyway, let's check this out. Oh yes, let's use the reset circuit. Put a redstone block there. Put a redstone block there. Wrong! Oh, but it did fire off, didn't it? It really did. It really did. Maybe we got to think about a little bit more complexly, a little bit more intricately about this. Is that even a way of phrasing that? Maybe we have to think carefully. That's what I meant to say. Okay. How do we do this in a better way? Oh, I see what's actually happening here. I see what's actually happening here. We have to... Let me think about this for a second. It's not actually enough just to put this redstone block here, because we're permanently giving this signal an input. What we have to do is say, if this has changed, then check it. How do we do that? How do we do that? Thinky. Okay, I'm going to clear this stuff away while I think. We only want it to trigger after the other person has selected. So let's place a second block here. Okay, let's move this stuff. I'll put a redstone repeater there and one there, and I'll put the command that's in here in the second block. And then I'll just put a line of redstone. This is similar to what we have on the other side. I'm just neatening it up so that I can have a long line of these things. Similarly, we go like this, and a couple of redstone blocks there. Copy this command. And let's just make sure that this works for the default case. So reset, pick, guess was correct. And we reset the circuit. Ping. Okay. Maybe what we need to do now is to say, we need to say if this is not true. In other words, we invert this. And we make an AND gate here. Okay. We make that AND gate there. Basically what we're going to say is, once someone guesses, put a redstone block here. And so that'll summon a block there, and it'll summon a block here. And only once this gives a signal, and if this has a signal, do we say wrong. Okay, does that make sense? Alright. Well, what is this block's coordinates? 829, 4, minus 858. 829, 4 minus 858, was it? I'll have a look again. Redstone block. Just summon it. Oh, nope, not exactly. 859. There we go. Okay. Let's put this redstone back. Let's say, okay. The third thing you summon is this redstone block for the detector of invalid values. Okay. Let's try this out. Reset everything. Player 1 picks. Player 2 guesses. Wrong. But it fired the TNT off at the same time. It's not actually supposed to say wrong, is it? It's supposed to compare. It's not actually supposed to do this. It's supposed to do a 3 AND gate. Okay, I'll figure this out sooner or later. Don't worry. Figuring this out as I go. This is the fun part. This is where you start to try and guess what the correct thing to do is. Okay. Let's make an AND gate here. Let's say you summon a block here. In fact, we can make this even more concise. Oh no, wait, we can't do that. We can make an AND gate here. Okay, basically we need 2 AND gates here. The first one is to say, okay, if both of these are picked and someone has summoned something there. So let's do it like this. I think this will work. Maybe this will work. Let's see. Okay, this goes into another AND gate here. You can see how this starts to get quite large in terms of the space that you need to do this stuff, right? Okay, here we'll say wrong. But actually what we need to do is if this is not true. That makes more sense. Okay, so if this is not true and this one is true, then we have an AND gate here. Okay, that looks promising. So if these aren't both on, we'll get an input signal here. We need to summon this thing as a redstone block. So what's this? 822, 4 minus 865. $865. Redstone block. Nope. 866. There we go. Okay, let's try this now. Reset. Pick. Guess the wrong thing. Resetting. Damn. Oh, that's right. We didn't actually make this side pick something. Where did the redstone block go then? Okay, reset. Pick something wrong. Resetting. Damn. Okay. Now we seem to have a kind of cross multiplication problem, because if we select the wrong thing, basically all of these checks need to fire exactly the same piece of redstone off, which is to say they all need to add a piece of redstone here and there, and however many buttons you've got, they need to add a redstone block to all of them. Okay, so this gets sort of tricky. But basically this is what we're going to do, right? I mean, we're going to have all of these things place a redstone block here. So let's look at what this would look like in theory. I'm not actually going to do it now because it's going to take way too much time to set up. But pick one here, and then pick the wrong one, and then place a block here. And it should say wrong. Wrong. Okay, let's try that again really quickly. Oh, what did that do? Set to none. Okay, if we assume every set of these command blocks places a redstone block at every point where there could be a combination, we can say something like, okay, now it's placed that block everywhere and says wrong, and then it resets the whole circuit. Now it doesn't reset this yet, so we'd need to add a redstone block at each possible combination from each circuit where the guess is made, and the reset would have to reset each of these redstone blocks that was placed. But this is still the circuitry we need. This works quite well actually. This is still the circuitry we need to guess when there are wrong values. And so just like we did TNT for if there was stuff that was right, we can do you know, fireworks or something. We could announce player 1 wins or player 2 wins. We could do all sorts of interesting things. This is about as far as I want to take this right now. So if you had fun, then let me know. You can let me know on Twitter at assertchris, or on Twitch at assertchris. Probably tweet at me on Twitter, or if you want to know when more streams like this happen, then just follow me on those things and I'll announce it on Twitter, or you'll get emails if it's on Twitch and I go live. So follow me on that stuff. Usually you'll find me doing PHP and JavaScript stuff because that's what I do day to day and it's the most fun for me. But I've been wanting to do Minecraft stuff for a long time, and I'm going to speak about it at a conference soon, so I thought this would be good to get back into the swing of things. And yeah, I had fun. I hope you had fun. But I'm going to go now. So thanks for being here, and thanks for listening and commenting, and you've been awesome. Enjoy programming and the rest of your evening or morning or lunch or feet. I don't know. I'm going to go.